So Vik is a guy I've known for a while. He is an expert in teaching data scientists. So today he's going to talk a little bit about how you do that at scale. So please welcome Vik.
All right. Thanks for the great intro, Rob. How's everyone doing? Hopefully well. I know there was a break supposed to happen, and it's always dangerous to be talking during people's supposed break time, but I'll try to make it good. All right, so as Rob mentioned, I am the founder of DataQuest. We teach data science online. So why should you pay attention to me? So I'm a former US diplomat. I'm also a self-taught data scientist. I've won a few Kaggle competitions in automated stock trading and a couple other things. And I also worked at edX, which is part of MIT, before starting DataQuest. All right, so my goals in this talk are to share how to effectively teach data science and to discuss how to build out data science teams, as well as discuss some of the trends that we've been seeing in the data science space. And hopefully this will be useful to you as you go back to your companies and think about how to apply data science in your day-to-day. So what is DataQuest? I mentioned that we teach data science online. We have about 500,000 students from 185 countries. We work with companies like Skyscanner, Edmunds, and Uber as well, although we're mostly B2C. We have a team of 25, and as Rob mentioned, we are bootstrapped, and we do all of our content development currently in-house, so we have an internal data science team as well. This is one of the early lessons on the DataQuest platform. As you can see, it's all interactive, so you learn some data science concepts, and you actually write code, and you get feedback on your code. We teach everything from the basics to much more advanced topics. This is a deep learning course, a screenshot from that. And you can see that we also teach the concepts and basics of neural networks as well. Our goal is to take you from zero to a data scientist or data analyst job. And we have about 50 courses on our platform right now. And at the end of every course, we actually have you build a guided project. So we walk you through using standard data science tools like Jupyter and actually building a project on your own. So what do we teach? So we have 3 learning paths right now. We have the data analyst path, the data scientist path, and the data engineer path. And I'll briefly go through each one. So data analysts need to organize data, answer questions, and share their results. And to do that, there's a variety of tools, but we teach Python and R, SQL, data viz, and stats, primarily for data analysts. We also teach a data science path to help people become data scientists. And data scientists really gather, organize, and clean data. They answer questions, they communicate results, and they also create machine learning models, which is the fancy part that everyone gets excited about. So I think of data scientist roles as a superset of data analyst roles with more technical depth. It's not just a data analyst who can do machine learning, and I'll talk more about that later. And then there's data engineers, an often overlooked but really critical part of the data science ecosystem. They create the data infrastructure, centralize the data, optimize query performance, and also operationalize the models. And general software engineering skill along with Python and SQL are really critical here. If you are a data engineer, you're an unsung hero. You don't get a lot of credit, but you do a lot of work. So who are our students? So I will talk briefly about this. About 35% of our students are in the US, and many of the rest are in Europe, India, and China. We've seen a lot of interest growing, particularly in India and China in the past couple of years. And only about 35% of our students are native English speakers, which is strange because we're written entirely in English, which just goes to show the interest in data science is really worldwide. It's also across industries. So this is a survey of a few of our more successful students asking what industries they're in. And as you see, tech is definitely represented, but you also see healthcare, e-commerce, education, finance, and we've seen these other industries tick up over the last few years as data science becomes more widespread. And let's talk about outcomes. So 62% of our students who finished more than 10 courses use skills in their job that they learned on DataQuest. And those job changers, so people who have changed jobs and use the skills in their job, have seen a mean 19K salary increase, which isn't bad for a $50 a month subscription. So why is data science important? If you're here, I suspect that you believe it is important to some degree, so I won't spend too much time convincing you. But if you think about Google, 84% of their revenue comes from ads. And basically, Google's business model, if I summarize it really, perhaps too much, it comes down to showing relevant search results and relevant ads to people. And there's really a few core algorithms there. And optimizing those algorithms, showing more relevant ads or more relevant search results, even a 1% increase in ad revenue through optimizing those algorithms is about $1.2 billion a year for Google. So data science is really critical to Google. But it's also critical to other companies where maybe they don't have a single core algorithm to optimize around. So Uber, you might think of pricing algorithms and routing algorithms, but they also use data science for customer service. They use natural language processing to improve how they do customer service. And they also use it for product improvements, measuring how people use the apps, measuring what buttons people click on, and doing A/B tests. So data science is really critical, not just in these kind of core, fancy, deep learning contexts you think about, but also just in general business and marketing and product and customer service. Really, data science is about iterative improvement. It's about adding business value. It's about understanding process, finding the leverage points in that process, and making recommendations to improve it. So what are the skills that it takes to really perform data science well in your company? So the first skill that I'm going to talk about is communicating results. And it's really, really critical and often overlooked. So look at these charts. So this is the same data in two different charts. And in the first chart, the y-axis is truncated. So it starts at 12%. So this is the percentage of people that are uninsured in the US by quarter. And if you look at this chart, you might feel like the percentage of people who are uninsured had a drastic dip. And it did, but not to the scale that you might think. So if you actually have a proper y-axis that starts from 0, you'll see that, that the dip is not as significant as you might initially have thought. And this is where communicating results properly and being able to frame them is really, really important. And here, you might see a false correlation. This is a chart from the South China Morning Post that shows the death toll in Iraq over time. And you can see, if you look at this chart just as a layperson, you may think that the death toll started high but went down and then went back up, but it's actually the opposite. So creating unclear charts can really tell the wrong story. And in this case, the story would have been, as US involvement in Iraq went up, the death toll went down, but it was actually the other way around. And skill 2 is really being able to question results. So being able to look at the results you found in data science and being able to dig deeper, being able to find the real story. One really interesting application of this is Simpson's paradox. So this is data from UC Berkeley in the 70s. And if you look at this, the piece on the left, it is the percentage of men and women that were admitted to Berkeley who applied. And if you look just on the left, which is what researchers initially looked at, you might think that Berkeley was biased against women. Because of the women who applied, only 35% got in, whereas of the men, 44% got in. But if you dig deeper and you look at it at a per department level, this is a little bit cut off. Okay, anyways. If you look at it per department, you see that men tended to apply to departments that were actually more rigorous, less rigorous in their admission criteria. So more men applied to departments where more people got in. And this is a little bit cut off, I apologize. So it is hard to see. But women actually tended to apply to departments that were more rigorous, where a lower percentage of women got in. So if you dug down and looked at the whole story, you actually found that there wasn't bias. Whereas if you looked at just the surface, you found there was. And this is where having a data scientist who can really dig in and get deeper than the surface can really help you. And the second issue is false correlation. So there is a website where you can play around with a lot of these, and it's really fun. But this is total revenue generated by arcades versus computer science doctorates awarded in the US. And if you just initially looked at this, you might think, okay, if more people are getting CS degrees, they may go to arcades, they may want to blow off steam. But if you dig deeper here and you look at the drivers behind the growth of both of those numbers, you'll see that they're really not correlated at all, and there's no real reason to assume that they are. The third skill is valuing solving problems over technologies. And this may be a controversial point because I'm going to poke a little bit of fun at deep learning and machine learning, which are important, but not the whole story with data science. So if you look at data roles at Netflix, they've actually decoupled their data roles. It's not just a data scientist. It's not just a machine learning engineer. But they've split it up into several different categories. And the reason they've done this is each of these roles has a different skill set and different value to add in different areas of the business. It's no longer kind of this all-encompassing data scientist role where you have to know everything, from deep learning to statistics to SQL. Instead, it's roles that add really key business value and solve problems. And the second example I'll give you is Medium Product Scientist. So Medium has a group of people called product scientists that analyze product data specifically. And this chart shows the correlation between post length in minutes, so how long, just the number of words divided by some constant, versus the total time people actually spent reading. So graphs like this really could help the whole company, the whole strategy. How do you optimize your content? How do you determine the right length for external contributors? And the fourth skill, which is really, really critical, is gathering and modeling data. Data cleaning and data organization, for folks who are data scientists, is 80% or more of the job. And it's a really, really key skill. So if you look at this chart, you can see the development of weekly working time in Europe. So you can see this as a series of dots. There's a lot of missing data here. And how you fill in that missing data can really change what the story looks like. For example, if you, in the case of Germany, how you draw the lines connecting the dots can tell the story of German work culture became much less strict relative to the rest of Europe over time, or it became more strict and then less strict. It just depends how you draw the peaks and valleys. And having someone that can interpret that data and interpolate it properly makes a big difference. And then finding the right features. This is a confusing chart, I know. Basically, it is looking at the sale price of a house correlated with other features of that house. So how many bathrooms it had, where the bathrooms were located, the square footage, et cetera. And the darker the dot is, the more that feature correlated with sale price. And this impacts the entire strategy of a company. So let's say you're Zillow and you want to predict the sale price of houses, or you're a real estate agency. What you need to do is start by gathering the right data, right? If you don't even have the right features, if you're not measuring the number of bathrooms in a house, you can't even model it effectively. And then how do you standardize that across houses, right? What does a half bath mean? Is that standardized across houses all over the world? How do you give a score to a neighborhood? What does that even mean? How do you judge neighborhood quality? And having data science really incorporated in the strategy there, not just, hey, here's a bunch of data, go make a model, makes a really big difference. So next I'm going to talk about the profiles of some successful DataQuest students. This may help as you hire data scientists or think about who to bring on in junior data science roles. This is Caitlin. She lived in Tampa. She now lives in Boston. She used to work in retail at IKEA. And she moved into a data analyst role after studying some data analysis at USF. She didn't learn a lot of programming there. It was more data strategy and using tools like Tableau. She learned machine learning and data science on DataQuest, and she moved into a role at Amazon working on Alexa. And this is Hezekiah. He is and was a student at Tufts. He learned data science on DataQuest as a supplement to what he was learning at Tufts. He did a couple of internships, and he's now working at Prudential, which is great. So what makes students successful? It's really building real-world projects. So if you're looking to hire a data scientist, if that data scientist has never worked on real-world data, that is a red flag. If it's clean data that they've never had to wrestle with or figure out the right features for, that is a red flag. So desire to solve problems and build context. Data science is not about, hey, I'm going to toss you an algorithm, or I'm going to toss you some data, you plug it into an algorithm, and you figure out the right answer. It's really, how do you integrate with the company to gather the right data, to model it, and to ultimately work with the people who are implementing your suggestions. It's communication skills. Unless you can create good presentations and communicate your results, you can't get organizational buy-in. Statistics is really, really critical. Some of the pitfalls that I've talked about earlier, you need statistics skills to overcome and be able to correctly model data, be able to figure out which average should you look at, what does this data mean, how do I know if a result is significant or not, and excitement and motivation around data science. If you look at data science as just a job, that's fine, but we find that the people who tend to succeed find something really exciting about data science and want to continuously learn. So let's talk about building data science skills in an organization, which kind of summarizes some of the things I've been talking about. So think about hiring data engineers before data scientists. Data engineers really build the infrastructure and the framework to let you practice data science successfully. Think about surveying for internal data science related pain points. A lot of people kind of bring in data science teams and they don't have a lot to work on. But data science teams fundamentally solve business problems and add business value. If data scientists don't really have a place in the company yet or any problems to solve, then it might be too early to bring them on. Get data science skills as close to the problems as you can. So Netflix has been splitting out those data science roles, as I mentioned, into to get them closer to the actual problems and the teams that need them. We've seen this at DataQuest as well. About 30% of our students don't have data scientists or data analyst titles. They work in marketing, they work in product, they work in customer service. And building data science skills can really help you if you are in those teams. The reason why, if you know SQL, you can build a cohort analysis if you're in product. If you know SQL, you can do a cohort analysis if you're in marketing as well. And having these skills embedded means that you're solving real problems and adding value from day one. Screen for communication skills and context. I just mentioned this, but I'll mention it again. Business context is really important. Just having people that build neural networks without any idea of how the rest of the business works is almost certainly not going to succeed. And look for stat skills, not just machine learning. And finally, I didn't touch on this much in the interest of time, but it is really important. Measure the success of your data science teams with KPIs. Look for some business metric or value that you can look at optimizing over time and see how that trends. All right, and then some trends in data science. We're seeing skills become decentralized in organizations. I talked about this a little bit, but a lot of the most successful companies, Uber, Airbnb, Netflix, they've been decentralizing data science roles. There's no one, in some of these companies, not all, there's no single data science team, but instead there's data scientists embedded into a lot of teams. Data science is being used in more industries. I'll skip the other two because I already talked about them. And finally, a quick plug. I mentioned DataQuest at the beginning. We work with companies and universities to help train their data science teams. I'd love to chat if you want to learn more about that, or even just talk about how to use data science in your company. I love talking about that stuff. So feel free to chat with me after or email me. I'm just vic@dataquest.io. All right, that's it for me. Any questions?
Great talk. I have a quick question. What about I employ a couple of data scientists, and I see a correlation with their success with an appreciation for the business, the product, the customer, and that wasn't in your list of skills. Do you agree that that's valuable?
Oh, yeah, that's absolutely valuable. When I said context, maybe I should have explained it more, but that's what I mean by context. It's really a passion and understanding of the business. So 100% on board.
Vic, when you look at the data science landscape and all the people sort of across the country that are working in data science, what percentage of them do you think would say that they work in artificial intelligence? Is it a small percentage? Is it most of them? What does that look like?
AI is interesting. It meant a very different thing 30 years ago than I think it means now. So I think the people that call themselves in the AI field are it's probably a very bimodal distribution. There's people that are older and kind of work at research labs, or there's people that are working on deep learning. I don't, maybe 10%. I haven't directly surveyed, but I don't think there's a huge overlap.
But most data scientists are not really working on artificial intelligence per se.
I don't think so, personally.
Gotcha. And what trend in data science is most interesting or exciting to you, something that's coming that maybe the rest of us haven't seen yet?
That is a good question. So I talked about two of the key trends, data science becoming more distributed across the world and data science becoming more and more relevant in different businesses. It's been really, really exciting to see data science growing in India, growing in Nigeria, just a lot of places you wouldn't expect.
Awesome. Any more questions? Yep.
Hey, what do you do to actually decompose the skills that you mentioned and the sub-skills that compose them, and how do you measure those skills?
Yeah, that's a really good question. So what we do is we actually survey the field. We look at what people are hiring for. We talk to hiring managers. We survey dozens of people, and then we work backwards to figure out the projects that students need to be able to build to be hired for and be successful in a role. And then in order to build those projects, we figure out what they need to learn. And we measure whether or not students have actually successfully learned something through our coding exercises. Can you actually code something? And through the ability to build projects. Can you build a project that demonstrates this knowledge?
Cool, thank you.
All right. Vic, thank you for your talk.